Hi, welcome to our next Level 3 simultaneous equations video. This is our first video on finding a range of solutions, which is the last area we're going to look at for simultaneous equations. Now we know for unique solutions we can find a value for x, y and z. We know when equations are inconsistent there are no solutions, so there's no further work to do. But when equations are dependent we have an infinite amount of solutions, and we can explore this area in more depth. Let's find the range of solutions for the following simultaneous equations. Well, I tried on my graphics calculator, it's given me a mathematical error, so it's either inconsistent solutions or dependent solutions. So let's use algebra to find out which is which. If we take equations a and b and multiply a by 15, we can eliminate the 15x with the 15x in equation b to get equation d. Then, if we pick two new equations, a and c, we can multiply everything in a by 25, so that eliminates with the 25x in equation c, and that gives us equation e. Now, if we take equation d and multiply everything by 10, and then we take equation e and multiply everything by 6. We go and do our subtraction, and this is where we get 0 equal to 0, which is our proof and justification that these equations are dependent. Alright, well let's explore this in further depth. We're going to go back and pick two equations. Now most of the time it doesn't matter which two, but there are some scenarios where we might pick two, and if we took the first equation up in this box and doubled it, it's exactly the same as the second equation, and that's not going to get us any further because we'll just get 0 equal to 0. So sometimes picking two is not going to help us, but in this example we're working on, we're going to ignore equation C and work with A and B. In fact, we're not going to need equation C again for the rest of the problem. We're going to start off by eliminating x. So once again, let's do our algebra. Multiply everything in a by 15. Write down equation b and do our subtraction. The 15x's eliminate. Now I'm going to go the bottom equation, subtract the top. So 21y minus 15y is 6y. 12z subtract 15z is minus 3z. And 12,570 take away 11,100 gives us 1,470. Now we're going to call this equation F. We're going to stick to the same two equations and we're going to now eliminate y. So let's repeat it but eliminate y. So we're going to multiply everything in equation A by 21. And write down equation B underneath and do our subtraction once again. So 21x take away 15x is 6x. 21y, take 21y, that eliminates y, is what we're trying to do at this stage. And 21z, take away 12z, leaves us 9z. And 15,540, take 12,570, gives us 2,970. We'll call this equation D. Right, well once again we're going to stick to the same two equations and we're going to repeat the process, but we're going to eliminate z this time. So to do that, we're going to multiply everything in equation A by 12. And we're going to write down equation B once more. And we're going to do our elimination process once more. Now again, I'm going to go bottom equation, take away top. So 15x, take away 12x, leaves 3x. 21y, take away 12y, leaves 9y. 12z's eliminate. And 12,570, take away 8,880. Leaves us 3,690. And we're calling this equation H. Right, so what we've done is take two out of the three equations and just work on those two, and we've eliminated x, then eliminated y, and then eliminated z to get three new equations, F, G, and H. We're going to use those three equations in the next video to progress with this problem. Thanks for watching.